to factoring pre-assessment. This is a comprehensive explanation of what we're going to have for our assessment on Wednesday. Step one, there are a couple parts. If we look at, let's take a look at the entire assessment as a worksheet. That assessment looks like this. So our first task is going to be factoring out the common factor of each expression. We're going to be turning each of these addition and subtraction problems into the product. So we're going to factor out that GCF, and then we're going to have it multiplied by whatever is left over. And then the second half of the assessment will be on factoring and producing two binomials. And so this is going to be A times C. We're going to be using the A times C technique when A, not this A, when A is 1, or when A is greater than 1, and also when C is positive and when C is negative. So those are the four major components. And then the third part is special cases. Special case number 1 deals with difference of squares. And then the second special case are binomial squares. And we're going to need to know those three criteria that we can visually see in order to signify that it's the difference of squares. And then we're going to also need to know the four criteria that signifies whether it's a binomial square. So those are the things, and that's what we're going to cover. And as you see, we have 45 questions, so this will be a long one. Let's get into it. Alrighty. So factoring out a common factor, we're looking at the terms, each term individually. When our first term is negative, we have to factor out a negative. When our first term is positive, we have to factor out a positive. So very important for us to determine whether we're factoring out a positive or negative. So we have negative x to the fourth and negative 3x squared. So we can factor out a negative 1, and now we have to see how many x's do they have in common. And they have x squared. So we can take out a maximum, and it's what of both of these can we put in the bucket that they have in common. So if we take out a negative x squared from negative x to the fourth, we're left with x squared. If we take a negative x squared from negative 3, we are left with positive 3. And how do we check to see if this is the correct answer? Well, if we multiply it back out, do we get the starting terms? Negative x squared times x squared gives us negative x to the fourth. Negative x squared times 3 gives us negative 3x. So this is the answer. When we have 15b squared minus 9b, the other way that you can do this, and we can visually, we are doing mental math. We shouldn't be writing things down in 8th grade. In 8th grade, it is assumed that you know how to find the greatest common factor of these coefficients and the greatest common factor of the variables. But I'll show you a technique on how to find the GCF, and we do that through prime factorization. So you take your first term, 15b squared, and we break it down into its prime factors. And again, at this point in 8th grade, you should be able to break 15 up into its prime factors. Notice those two numbers are prime. And then we have negative 9b. So that's negative 1 times 3 times 3 times b. Now, GCF, if we're going to find the GCF of those two terms, we want to find out, we circle what they have in common. So what do these have in common? Well, they have a 3 in common. They don't have a second 3, and they have a b in common. So this represents the GCF. So the GCF, the largest factor that I can pull from these two terms is 3b. So I'm going to put the 3b on the outside. And then if I take 3b from 15b squared, we notice that we actually get to see what is left over. So that's going to go inside the parentheses. And then we again look and see what do we have left over after taking 3b from negative 9b, and that leaves us with negative 3. So this actually is a really nice way of showing the factor, when you factor out the GCF, what you have left. So this technique is valuable, it's time consuming. And in order to be efficient and to add to your time bank, we really need to be able to do this visually and mentally and looking at these terms. So when we look at these terms, we look at the coefficients first, 40 and 10. Greatest common factor of those two coefficients is 10. K to the fourth, k squared. I can take out a maximum of k squared. If I take that from 40k to the fourth, that leaves me with 4k squared. And if I take a 10k squared from 10k squared, I'm left with 1. So all of this should be done that fast, that mental math, and this should be something that is relatively a warm-up drill for the next section. Negative 36x to the fourth, we have to notice that we have a first term negative, so we're going to have to factor out a negative. And then we look at the coefficients, 36, 8. Let's say that I saw 4. Okay, so let's say, or let's say 2. Let's say I factored out a 2, and I did 2x squared. So if I take out a negative 2, that leaves me with 18 and x squared. And if I take out a negative 2, that's going to leave me with negative 4. So how do I know that there's a visual recognition of this is not the greatest common factor. And that visual is, well, I can still take a 2 out of there. So I know that this is not the GCF. So if I was looking for the GCF, it would actually be negative 4x squared. And then if I factor that out, I get 9x squared minus 2. And again, we can multiply it back out. So this is the correct answer. Correct answer. And this is not simplified. It's not simplified enough because we could still factor. Still has a common factor. Still has a common factor. So this would be marked wrong. This answer would be marked wrong. This is the correct answer. You must take out the GCF. So be careful of that. 10n to the fifth, 30n to the fourth. So we look at the coefficients. We can take out a 10, n to the fifth, n to the fourth. I can take out a maximum they have in common, n to the fourth. That leaves me with n plus 3. Okay, first term negative, so I got to take out a negative. 56 and 72, that would be 8, so negative 8. Now this has x squared, this has x, this has no x, so I can't take out an x variable because not all three of them share it in common. So if I take out negative 8 from negative 56x squared, I get 7x squared. And if I take out that from negative 56, I get 7x. And if I take out that, that's going to leave me with a positive 9. So 7 times 8 is 56. And that would be the correct answer. 90, 45, 9. I'm going to pull out a 9. Each of them have at least an x. So that leaves me with 10x to the third plus 5x, and that's going to be minus 1. Multiply it back out just to make sure that I get my starting problem. Yep, that's the easy quick check. I'm going to factor out a negative 3, and that's it. That gives me 6n to the fourth plus 2n plus 7. And I can look here, did I factor out? There's no common factor left. Much like back here, we saw there was still a common factor left. So that was my eyeball. There's no common factor here, so I knew I took out the GCF. So that's a nice little visual check that you can apply. 8n to the third, negative 24n plus 4. We can take out a 4. Can't take an 8 out because we can't take an 8 from 4. So our largest number that can be divisible into each 3 of these terms is 4. So 2n to the third minus 6n squared plus 1. 20, 25, 25, 5, no p, so this is 4p squared minus 5p plus 5. Yep, good. Now we have to factor. So we have this number of lists that we go through. Number one, is it in standard form? We should always make sure that our expression is in standard form. A squared A, no variable, standard form. Is there a common factor? So is there still a common factor that can go into this? No, they don't share a variable. No, they don't share a coefficient. Is it a special case? Is it the difference of squares? No, because difference of squares is 2 terms. Or is it a binomial square? And binomial squares are 3 terms, but our third term has to be positive, so it is not a binomial square either. So we're going to technique number 4 on how to factor, and that is A times C. Now, A times C comes from this template, A squared plus BX plus C, where A is the coefficient of x squared. So, or my squared value. So A is going to be 1 here. B is going to be the coefficient of my B value, to my first value. And C is going to be my constant. So when I say A times C, I'm talking about the A value, or 1, times the C value, which is negative 24. Which gives me negative 24. Now I'm going to find factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. No 5. And once we get to 6, we go around. Now, my next thing is going to be putting the signs for these variables. So we need to utilize this. So we're going to use this little thing here. Let's look at this. This was notes from students who stayed over for office hours this afternoon. So very important to determine how we determine the signs. First, we're always going to look at our coefficient, our C value. If C is positive, I know the signs are the same. So if I look at this sign and it's positive, I know they're the same. Now I have to look at this sign here for my B value to determine what they're the same. Are they the same? Are they both negative or both positive? In this case, they're both negative. So you see that I would make my signs both negative for my factor pairs. And if the first sign is positive, meaning they're the same, and then I come here and this is a positive, I know that both are positive, so I would assign both positive signs. So we're always going to look at my C sign. Is it positive or negative? If it's positive, I know the signs are the same. If they're negative, like this, if the signs are negative, if this sign is negative, then I know the signs are different, meaning one is going to be positive and one is going to be negative with my factor pairs. And so when I see that the signs are different, I'm going to go to this first sign, my sign of B, and if it's negative, I know the bigger of the 2 factor pairs are going to be negative, and if they're different, then the other one has to be positive. In this case, I knew my signs were different, and then I went over here, and the bigger was positive. So the bigger of the two factor pairs gets the positive sign, and I know the signs are different, so the other one has to be negative. So that's how we're going to use those signs. So in this case, we look here first. We always look to this sign. If this sign is negative, that means the signs are different. One's positive, one's negative. And then I go over to here and I see that the bigger of the two is negative. So the signs are different and the bigger is negative. So I'm going to go over to my factor pairs here and I'm going to find the bigger of the two, which is 24. 24 is bigger than 1, and I'm going to assign it that negative. And since the signs are different, I'm going to make this one positive because they can't be the same. This is the bigger of the two factor pairs. That gets the negative, and the positive would be on the other one. This is negative. This is negative. And now we're going to combine them. This gives me negative 23. This gives me negative 10. This gives me negative 5. This gives me negative 2. So the product has to equal negative 24, and the sum equals this. And we're looking to see which sum equals my middle value, negative 5. Which one of those equals negative 5? Well, that's the one that equals negative 5. So I'm going to take these two terms, positive 3 and negative 8, and I'm going to rewrite this trinomial into 4 terms. And I'm going to split this middle term. And I'm going to write positive 3a and negative 8a minus 24. So I brought down this value. I brought down this value, and this value was created by this, because positive 3a and negative 8a produces negative 5a. So I didn't change the equation, I just split this term into 2 terms. And now I'm going to group. I'm going to group factor by grouping. I'm going to group these two, the first two and the last two. And now I'm going to look and see what is the greatest common factor of these two terms. That would be a. And that leaves me with a plus 3. And I'm going to factor out what? Well, I have to notice that my first term is negative, so I'm going to factor out a negative 8. If I factor out a negative 8 from these two, I'm left with a plus 3. And that quick check is to distribute it back out. Negative 8 times a, yes. Negative 8 times 3, negative 24, good. So I know if I did it correctly, if these two parentheses are the same, they have to be the same. Must be the same. If they're not, then I made a mistake somewhere and I got to go back and check my work. But these are the same, so I'm going to factor out an a plus 3. If I factor out an a plus 3, I'm left with a minus 8. Now this order doesn't matter. It can be a minus 8, a plus 3, but where did I get the a minus 8? I got that from here, so that produces my other binomial. I'm going to pull this binomial out, and if I factor it out, it leaves me with the a minus 8. And that's how we factor using a times c. So let's do this a little bit faster. So is it in standard form? Yes. Is there a common factor? No. Is it a special case? Is it the difference of squares? No, it's not 2 terms. Is it a binomial square? No. Now, binomial square, third term is, it has 3 terms, third term is positive, but this is not a perfect square, so we know it's not a binomial square. So we go to step 4, a times c. My a is 1, my c is 8. 1 times 8 is 8. Factors of 8 are 1 and 8, 2 and 4, and now we're done. Signs are the same. Since it's positive, that means signs are same. And now we look to the secondary indicator, and that tells me that both of the signs are positive. So I'm going to put those signs in there. Positive, 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 positive. 1 plus 8 is 9. 2 plus 4 is 6. Which one is equal to my middle? 9. So I'm going to pull these two values, 1 and 8, and we have r squared plus 1r plus 8r plus 8. Where did I get these two numbers from? Right here. I'm using 1 and 8. 1 and 8 as my coefficients on splitting that. Now I'm going to factor by grouping. What is the common factor between r squared and r? That would be r. If I take an r, that leaves me with r plus 1. Let's look at 8r and 8. Common factor is 8. That leaves me with r plus 1. Are the two parentheses the same? Yes, they are. R plus 1. If we factor that out, I'm left with r plus 8. And that would end. If you want to check, you can multiply it back out. R times r is r squared. Outside, r times 8 is 8r. R times 1 is r, 8r, and r makes 9r, and then 1 times 8 is 8. So this product of these two binomials creates the starting problem. Okay? Standard form, yes. Common factor, no. Special case, no. A times c. So a is 1, c is negative 44. 1 times negative 44 is negative 44. So factors of 44 are 1 and 44, 2 and 22, 3 no, 4 yes, 4 and 11, 5 no, 6 no, 7, 8, 9, 10, and then we're back around 11. So those are my factor pairs. My sign, if I look to this sign, if it's negative, that means it's different. Signs are different. And the bigger is positive. So bigger is positive, bigger is positive, bigger is positive. And this gives me 43, this gives me 20, this gives me 7. Which one is equal to my middle? 7. So I'm going to take negative 4 and 11. Actually, it wasn't a very good. There we go. Negative 4 and 11, so we'll rewrite it. M squared minus 4m plus 11m minus 44. Let's factor by grouping. Factor out an m minus 4, factor out an 11, m minus 4. We get m minus 4, m plus 11. That is our answer. And the more practice you get, the faster you can work, and the more efficient you work. Not special case. A times c, 1 times 66 is 66. And this teaches you also good times tables, because when you find factor pairs, you're using your times table. 1 and 66, 2 and 33, 3 and 22, 4, no, 5, no, 6, yes, 6 and 11, and that's it. My signs are the same because that's positive. They have to be the same, and then I look here, and they're both negative. So negative, 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 negative. This gives me negative 67, negative 35, negative 25, and negative 17. My middle term is negative 17. So I'm going to pull these two values, negative 6 and negative 11. P squared minus 6p minus 11p plus 66. Let's take that. Let's take that. Factor out a p. P minus 6. Factor out a negative 11. P minus 6. Check it real quick. P times p squared, p times, yes, that's good. That's good. These are the same, so pull out the p minus 6, and you get p minus 11. Standard form, common factor, no. Special case, no. 56, not a perfect square. And third term wasn't positive. A is 1. C is negative 56. Negative 56. 1 and 56 2 and 28. 3, no. 4, yes. 4 and 14. That's a weird one to know that 4 times 14 equals 56. 5, no. 6, no. 7, no. 8, yes. 8, oh, 7, haha. And now, so the question is, Mr. Mack, why didn't you just do 8 and 7? Well, I want all my bigger to be on the right side. So doing this might get me into some trouble when I start assigning signs. So I always want my factor pairs to be in numeric order. It helps me, it saves me, especially in this case when the signs are different. So the signs are different and the bigger is positive. So the bigger is positive, so I know all my numbers on the right are going to be bigger than my numbers on the left because I did them numerical order. So bigger is positive, that gets negative, that gets negative, that gets negative. And now we're going to add them. That gives me 55, 26, 10, and 1. And this coefficient is 1. So I'm going to use -7 and +8, x squared minus 7x plus 8x minus 56. I'm going to factor by grouping. I'm going to factor out an x. I get x minus 7. I'm going to factor out an 8, and I get x minus 7. And that gives me x minus 7, x plus 8. Awesome. We're just rolling right along here, kids. Oh, look at this. My a value is greater than 1. So we're still going to make sure it's in standard form, r squared r, no variable. Here we have to start being careful. Is there a common factor? Now that there's a coefficient greater than 1, we may have a common factor, but this is 1, so no common factor. Is it a special case? It's not difference of squares because there's 3 terms, and it's not a binomial square because these are not perfect squares. So we'll go back to a times c. A is 2. C is -28. 2 times -28 is -56. And we again have 1 and 56, 2 and 28, 3 no, 4 and 14, 5 no, 6 no, 7 yes, 7 and 8. My signs are going to be different because it's a negative. I'm just looking at this sign. I'm not looking at both of these signs. I'm just looking at the third term. If it's negative, then it's different. And this tells me that the bigger is going to be negative. So negative, positive, negative, positive, negative, positive, negative, positive. These signs have to be different from each other. This gives me -55. This gives me -24. This gives me -10 and -1. Oh, this time -1. So now I have +7 and -8. 2r squared plus 7r minus 8r minus 28. I'm going to group the first two. I'm going to group the second two. I can only factor out an r. That leaves me with 2r plus 7. I have to factor out a negative. So I have to factor out a -4. Yeah. And that gives me 2r plus 7. I know I did it correctly because the 2 parentheses are correct, or the same, identical. So I'm going to pull out that 2r plus 7, and that leaves me with r minus 4. And that's how you factor when a is greater than 1. Standard form, yup. Common factor, close but no. Special case, no, 10 is not a. And a times c. So a is 2, c is 10. Factors of 20, 1 and 20, 2 and 10, 3 no, 4 and 5. And I'm done. This means my signs are the same. when it's a positive, and they're both positive. So positive, 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 positive. 21, 12, 9. 9 is my middle term, so I know it's going to be these two groups. It's not always going to be the bottom one. I know it seems like it, but it won't be, I promise. So 2n squared plus 4n plus 5n plus 10. 10 comes from here, the 2 comes from here, and this 9 is just being broken up into two products, so we can factor by grouping. We can factor out a 2n. Ooh, I like that. N plus 2. We can factor out a 5. That's n plus 2. I know I did it correctly. N plus 2. 2n plus 5. And that is our answer. Okay. Standard form. Yes, it's in standard form. Common factor. No. Special case. No. And let's do A times C. A is 5. C is 3. 15. Factors of 15 are 1 and 15. 2, no. 3 and 5. And we're done. This is a positive, so positive means the signs are the same. And if they're the same, we look here and they're both negative. So negative, 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 negative. Let's combine them. Negative 16, negative 8, negative 8. Yes, it's the bottom one. 5r squared minus 3r minus 5r plus 3. Ooh, this is a fun one. Factor by grouping. Group those, group those. Let's factor out an r. Leaves me with 5r minus 3. Notice that that's a first term negative. Many students are going to make a mistake. Oh, and what am I going to take out? They don't have anything in common. So I'm going to take out a negative 1, which gives me 5r minus 3. Yes, look at that. That's a tricky one. That's a good one. So I know I did it right because the insides are the same, 5r minus 3. And if we take that out, we're left with r minus 1. Ooh, 18. Bonus problem. Love it. Standard form, no. Common factor, almost. So close. Special case, no. 12 is not a perfect square. A times C. A is 3. C is 12. 36. 1 and 36. 2 and 18. 3 and 12. 4 and 9. 5, no. 6 and 6. Same. Signs are same. And they're both negative. Negative, 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 negative. Negative 37. Negative 20. Negative 15. Negative 13. Negative 12. 20, yay! It's not the bottom one. 20, negative 20. So we're going to use these two numbers as my middles. So 3r squared minus 2r minus 18r plus 12. Factor, group and group. Factor out an r, leaves me with 3r minus 2. I have a negative first term, so I got to factor out a negative 6. I think 6 is our biggest common factor, and that leaves me with 3r minus 2. And I know I did it right, so 3r minus 2 and r minus 6. Boom. Standard form, common factor, special case, nope, nope, and nope, or yes, no, no. A times C, we'll use this technique, 7 times 6, which is 42, 1 and 42, 2 and 21, 3 and 14, 4, no, 5, no, 6, yes, 6 and 7. Addition means they're the same and they're both positive. Positive, 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 positive. We got 43, we have 23, we have 17, and we have 13. Yay, another weird or different one from the bottom. So we're going to use positive 3 and 14. 7r squared plus 3r plus 14r plus 6. Group the first two, group the second two. What do these have in common? An r, 7r plus 3. What do these have in common? A 2, and that's 7r plus 3. 7r plus 3, and r plus 2. All right, we are almost halfway done. Wow, almost halfway done, and how many more? How do you do this? Well, this is great practice. You want to be doing a lot of these back and back to back to back. So you get into the test, and it seems like it's super easy, like it's first grade work. Special cases, no. A times C. A is 12. C is -6. That's a big number. 72, I think that is. Yep. So 1 and 72, 2 and 36, 3 and 24, I think, right? 6, yep. 4 and 18, 5, no, 6, yes, 6 and 12, 7, no, 8, yes, 8 and 9. How many people remembered that one? And that's it. Negative means the signs are different. And then I go here, and the bigger is positive. So positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. This gives me, sorry. Don't start changing things up, Mr. Mac. This gives me 7. I did it again. Go to buy. 71, 34, 21, 14, 6, 1. Which one's equal to my middle? 71. That's this one. That's top one. So we got 12m squared minus 1m plus 72m minus 6. Group those. We can factor out an m. That's 12m minus 1. Factor out a 6, and that is 12m minus 1. 12m minus 1 and m plus 6. Good. When I look at your work, I should see all of this. I should see the same exact process. Standard form, yes. Common factor, no. Special case, absolutely not. A times C. A is 10. C is -12, -120, 120, 260, 340, 430, 5, and what's that? 14, 24, nice try, Miss Mac. 6, yes, 6 is going to be 20. 7, I'm going to need more space. 7, no. 8, yes, 8 and 15. 9, no. 10, yes, 10 and 12. There we go. Okay. I look at the third term, and that is negative. That means my signs are going to be different. And I look here and find that the bigger of the two is negative. Negative positive, negative, 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 positive. All the bigger terms are on the right, so they get the negative. All the terms on the left are going to be smaller, so they get the other side of that sign. The signs have to be different. Negative 119, negative 58, negative 37, negative 26, that is negative 19, negative 14, negative 7, and negative 2. My middle was negative 19, so we're going to use positive 5 and negative 24. 10a squared plus 5a minus 24a minus 12. Group them, group them. Let's take out a 5a. Leaves me with 2a plus 1. Factor out a negative 12. Leaves me with 2a plus 1. So my answer is 2a plus 1, 5a minus 12. Oh, yeah. Oh, no way somebody next year in your high school does this specific problem with this many factor pairs and finds the answer as fast as you do. This method is so efficient. Standard form, common factor, special case, a times c. A is 6, C is negative 4. Whoa, that was not an attractive negative 4. Negative 4 gives me negative 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. You're going to get really good with your factor pairs. Negative means they're different, and the bigger is positive. Negative, 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 23, 10, 5, 2. Middle term is 5. Let's take negative 3 and positive 8. 6n squared minus 3n plus 8n minus 4. 3n is the common factor, leaves us with 2n minus 1. Factor out a positive 4, because my first term is positive. 2n minus 1. 2n minus 1, 3n plus 4. Good on you. Oh, I like this. They're very similar, very similar. Oh, look at that. They're just flipped. That will be interesting to see how our answer, standard form, common factor, special case, a times c. So a is 4 this time, c is negative 6. We still get negative 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are still different, but this time the bigger is negative. So negative, positive, negative, positive, negative, positive, negative, positive. Was that the case in the other one? No, bigger was positive on that one. So what do we get? We get negative 23, negative 10, negative 5, and negative 2. Again, negative 5. Well, not negative 5. Again, 5 is my middle term. So I'm going to take these two terms, positive 3 and negative 8, 4n squared plus 3n minus 8n minus 6. Group them, group them. Factor out an n, we get 4n plus 3. Factor out a negative 2, we get 4n plus 3. This answer is 4n plus 3, n minus 2. How did these two differ? Oh yeah, differed completely. Wow, that's cool. So that's really, really neat to see that just flipping those changed a lot of stuff. I like that problem. I like it a lot. Good problem for us. Standard form, common factor, special case, A times C. A is 6, C is 12, 72, 1 and 72, 2 and 36, 3 and 3. What do we got? 3. 3 and 24. 4 and 18. 5 no. 6 yes. 6 and 12. 7 no. 8 and 9. Signs are the same. Both are negative. Put those in there. Negative 73, negative 38, negative 27, negative 22, negative 18, and negative 17. Oh, negative 73. We're way up the top here. Negative 1 and negative 72. 6x squared minus x minus 72x plus 12. Factor out an x, 6x minus 1. Factor out a negative 12. You get 6x minus 1. Oh boy, that's a good one too. 6x minus 1, x minus 12. Number 25, we're moving. So look at this. Beep, 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 beep. I haven't even gone through my list. And this should throw up a red flag. What is the red flag that we should be noticing at this point? Yes, there's only 2 terms. That should definitely, wow. So we better slow down. Is it in standard form? Yes. Is there a common factor? No. Is it a special case? The first special case is difference of squares. And difference of squares has 3 characteristics. First one is 2 terms. Does this have 2 terms? Ding, ding, ding. 1, 2, 2 terms, yes. The second criteria is subtraction. Is it subtraction between those 2 terms? Ding, 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 ding. And the third one is both of the terms are perfect squares. Are both of them perfect squares? Is there a number that you multiply by itself to get it? Yep, they are both perfect squares. So they are going to be produced by conjugates. This is the difference of 2 perfect squares. And the difference of 2 perfect squares is produced by conjugates. Conjugates are identical but opposite signs. How did we come up with r and 7? Square root of r squared is r. They go in as our firsts. Square root of 49 is 7, and those go in as our lasts. And then we give it different signs. The reason being is if we multiplied this out, our outside is 7r, our inside is negative 7r, and they would cancel. That's why there's no middle term. We only have 2 terms here. So that is the proper way. Is this the difference of 2 squares? We should automatically look and see when we see 2 terms. That should absolutely, is it the difference of squares? And yes, it is. It is 2 terms. It is subtraction, and both are perfect squares. So we're going to take x minus 2, and it doesn't matter if it's x minus 2, x plus 2, or x plus 2, and then x minus 2. These signs just have to be different. Okay, they have to be conjugates because that's what cancels out the middle term. Okay, standard form, common factor, special case. Is it the difference of squares? 2 terms, yes. subtraction, yes. Both perfect squares, yes. So square root of a squared is a, square root of 100 is 10, and we do plus minus, and that would be conjugates. That's what the difference of squares produces. Standard form, common factor, special case. We're testing difference of squares. Difference of squares has two terms. So does this. Difference of squares has subtraction. So does this. And difference of squares, both of the terms are perfect squares. So is this. So it is the difference of squares. So p minus 5, p plus 5. Standard form, common factor, no. Special case, maybe difference of squares. Does it have two terms? Subtraction, both perfect squares, yes. R minus 4, R plus 4. Square roots, you should know your square roots. San Francisco first. Standard form, yes. Kentucky Fried Chicken, no. Southern California, maybe dead on the street, difference of squares, subtraction, two terms. Getting tired. It was a long video. Difference of squares is two terms, subtraction. Now here's where it gets interesting. Are both perfect squares? Perfect square, yes, yes, yes. Okay, so square root of 81 is 9. Square root of v squared is v. Square root of 64 is 8. So we go 9v minus 8, 9v plus 8. Oh yeah. So difference of squares, two terms, subtraction, both perfect squares, yes. 5k minus 2, 5k plus 2. Don't forget to take the square root. It is not dividing by 2. It is taking the square root. Two terms, subtraction, both perfect squares, yes. 6x minus 5, 6x plus 5. Two terms, subtraction, both perfect squares, yes. 7m minus 6, 7m plus 6. Knowing your perfect squares are very important so you can recognize the difference of squares. 10m minus 7, 10m plus 7. Oh, all right, now we should notice, oh, slow down, it's not two terms anymore. So let's slow down, go back. Is it in standard form? Yes. Is there a common factor? No. Is it a special case? And is it the difference of squares? Nope, because difference of squares has two terms. This is three terms. The other difference of square, or the other special case, was binomial square. So let's go over the four things that binomial square has. Binomial square has three terms. Does this have three terms? 1, 2, 3, yes. The second criteria is third term is positive. Is the third term positive? Yes. The third criteria is first and third terms are perfect squares. Is this a perfect square? Yes. Is 144 a perfect square? Yes. Okay, and the fourth criteria. Does the absolute value of your middle term equal 2 times the square root of your first term times the square root of your last term? So the absolute value of negative 24r equal 2 times the square root of your r squared times the square root of 144. So the absolute value of negative 24r is 24r. 2, what's the square root of r squared is r. Square root of 144 is 12. Does 2 times r times 12 equal 24r? Yes, it does. So That tells me that this is a binomial square. I know that this is going to be a squared value. Okay, it's going to binomial. So I take the square root of my first term, I take the square root of my third term, and then I know my signs are the same, and I know they're both negative. So I put a negative in there. So that is the quantity of r minus 12 squared. That's how you do binomial squares. Now, if you didn't see that it was a special case and you did a times c, it would still work as a times c. So don't worry. Well, you should worry, because in 8th grade we should be figuring out and we should recognize special cases. Those are really important, but fail-safe is a times c still works. So standard form, common factor, special case, not dead on the street, not difference of squares. Is it a bologna sandwich? Is it binomial square? Are there 3 terms? Yes. Is the third term positive? Third term is positive, yes. Are the first and third perfect squares? Perfect square, perfect squares, yes. Does the middle term, absolute of the middle term, equal 2 times the square root of the first times the square root of the last? Does my middle term, absolute value of negative 2k, which is 2k, equal 2 times the square root of the first, which is k, times the square root of 1, which is 1? Yes, it does. So I know I'm going to produce a binomial square. I take the square root of the first, I take the square root of the last, signs are the same, and both are negative. So it's going to be k minus 1 quantity squared. Let's keep doing this. So standard form, common factor, special case, not the difference of squares. Is it binomial square? Does it have 3 terms? 1, 2, 3. Third term positive. First and third are perfect squares. And does 6x equal 2 times the square root of my first times the square root of my last? Yes. So I know that that's a binomial square. Take the square root, take the square root. Signs are the same, both are positive. It can be that easy. 3 terms, third term positive, first and third are perfect squares. Square root doubled, equal negative 6, yes. This is going to be k minus 3 quantity squared. Signs are the same, both are negative. Square root, square root. I'm not just taking the square root when I see this. I got to make sure that when I take this square root and multiply them and double it, it equals. In this case, it does. It's v plus 4 quantity squared. Let's check this. So let's slow down a little bit. Standard form, common factor. No, not a common factor. 3 goes into these, but not this, and 4 goes into these, but not this. So no common factor. Special case, it's not the difference of squares. Is it a binomial square? Does it have 3 terms? 1, 2, 3, yes. Is the third term positive? Yep, third term positive. Are the first and third terms perfect squares? Perfect square, perfect square. And does the middle, 24n, equal 2 times the square root of the first, which is 4n, square root of the last, which is 3. 2 times 4 is 8 times 3 is 24n. Yes, good. So that works. Now, I'm going to take the square root of the first, 4n. I'm going to take the square root of the last, 3. Signs are the same, both are positive, and it's a binomial square. So I got to make sure that I write that square in there. Students tend to make mistakes. So we got 3 terms, third term positive, first and third are perfect squares. Now let's look. 56p, does that equal 2 times 7p times 4? So that's 7 times 8 is 56. Yep. So I'm going to get 7p. I'm going to get 4 quantity squared. Signs are the same. Both are positive. Let's erase that little curly Q there. 3 terms. Third term positive. First and third are perfect squares. 2a times 3 is 6a, doubled equals 12a. Yes. And that's how you're going to do it in high school. You're going to do it that fast. And you're going to take square root, signs are the same, both positive, and you're going to write it. Whoa, okay. I'm not going to do this fast. I'm going to look and see, does 180b equal 2 times, that's 9b is the square root, 10 is the square root, that's 18 times, yeah. So now this is the easy part. Take the square root. Take the square root. Signs are the same, both are positive, and write it as a quantity squared. Last one. What? We got super easy on the last one? Yes. Now let's say we didn't see, right? These are 3 terms. Third term is positive. First and third are perfect squares. And let's say I forgot the formula. So let's say I go standard form, yes. Common factor, no. What if I don't see that it's a special case and I go to a times c, even though it is a special case? It is the difference of squares, or binomial squares. But let's say I do a times c. A is 1, c is 81. 81 factors of 81 are 1 and 81. 2 no, 3 and 27. 4 no, 5 no, 6 no, 7 no, 8 no, 9. Yeah, 9 and 9. So this is a positive, so the signs are the same. Both are positive. So positive, 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 positive. That's 82. That's 30. This is 18. My middle is 18. So I have 9 and 9. So p squared plus 9p plus 9p plus 81. Let's group and group. Let's factor out a p. We get p plus 9. Factor out a 9. We get p plus 9. These are the same, so we factor out the p plus 9, and it leaves us with p plus 9. I'm okay with this answer. If you want to write it as the quantity of p plus 9 squared, I'm okay with that also. I don't mind whichever answer you get. But this is an example of not seeing that it was a special case, it was a binomial square, and still using a times c and getting the right answer. So that's a great example of showing that you can still use a times c. A times c would work for all special cases. All right, good luck. This is a long video. Hopefully you did well, and I will see you tomorrow for the test.